Okay, let's start chapter 3, question number 38. We're going to have two banks here. We'll start with Bank A, and we'll draw a timeline for them. And it's going to look like this. Bank A, Derek's going to deposit $100 a month for the next 10 years. So he's making a total of 120 deposits. And the bank is going to pay 12%. It's compounded monthly. So what we can say is, look, he's going to make 120 deposits, and the interest rate is 12% annually divided by 12. The payments are $100. Present value is 0. I plug all that in, press the future value key. That's the value at month 120, because that's the value when the payments stop, and that's going to be $23,003, and I think I wrote 87 cents. It turns out to be a 1 or a 9. You're probably right and I'm probably wrong. Bank B is going to be like this. They're going to pay, Derek's going to pay the same total amount of money, but instead of making monthly deposits, he's going to make annual deposits. And those deposits are going to be $1,200 every year for 10 years. And the question is, what interest rate does Bank B need to have to make these equivalent? So 10 payments of $1,200. You start out with nothing, but those payments need to be worth $23,003.87. That's because V120 there's 120 months, which is the same thing as the value year 10 here, which is the value when these payments stop. So plug this into my calculator, interest rate, and you'll need to make the payment here negative, or the future value negative, one of the two. Make future value negative, you can see that better, I think. That's going to come out to be 13.8214%. Okay, let's move to question number 39. Alright, 39, we have Money Machine A and Money Machine B. What happens with A? Pays $2,000 per year for 10 years. So 0, 0, 1, 2, here's 5, here's 10. It's going to pay $2,000. I'll just put the 2 every year for 10 years. This is Machine A. And then let's do in red, Machine B is going to pay $20,000 5 years from today. Which machine is more valuable? The interest rate is 7%. Well, N is equal to 10, payment is equal to 2,000, interest rate is 7%, future value is equal to 0. Plug all this in, get your present value, that's the value today, times 0, and that's going to be for Machine A, 14,047.16. For Machine B, I can say the value today is equal to the $20,000. I think this way is faster. You could use these different functions if you wanted. 1.07 to the fifth, that's equal to 14,259.72. So Machine B is the better one. Question number 40 says, does the interest rate matter? So play around with the interest rate. Put low numbers in, put high numbers in, and it turns out that if R is greater than 13.0581%, machine A is better. This means A is better. And if the interest rate is less than this amount, it means B is better. And I'm not as interested in you finding that particular number, but what I want you to recognize is that the interest rate can determine what your choice is going to be. It's not always going to be one's better than the other. It's one better than the other at this particular rate, but sometimes a different rate is going to give you a different answer. Okay, so let's go on to question number 41. So 41, you're considering loaning Caspian Sea Drinks $250,000. They're going to make 6 equal payments. The first payment will be made next year. So we'll make it look like this. So you're going to loan them $250,000, and they're going to make payments over the next 10 years. So payment all the way up to year 10. So what will that look like? N is equal to 10. Let me do the interest rate next. The interest rate you require is 6%. Future value is 0 because there's no additional, and this will come up big in future chapters, there's no additional amount there. Present value is 250. By additional amount I mean there's nothing extra at year 10. That's what future value means. So plug this into your calculator, solve for payment, and that payment is going to be equal to $33,966.99. Okay, let's take a look at number 42. Which loan has a lower interest rate? Do it like this. Let's look at loan A. We'll draw the timeline for it and determine what its interest rate is. It's $100,000, and so minus 100,000, and we have 5 payments, 1, 2, 3, 4 to 5 of $23,000 each. And loan B, we'll draw its timeline as well. It's going to be a loan for $225,000, so times 0 minus 225, and it's going to have 7 payments of $40,000. So I just want to see which one has the lower interest rate. So this is really just getting you to understand what that interest rate means and being used to doing this on your calculator. N is equal to 5. Payment is equal to $23,000. You could just put 23 if for present value you just put 100. Make that minus 100,000. Future value is 0 once again because there's no additional payment here at the end. Plug that in. Find the interest rate, and that's 4.8472%. And then for B, there are 7 payments. Those payments are $40,000. The present value, will need to make that negative. Once again, you know, the calculator is thinking here you're going to pay money and receive money at different times. The signs just have to be opposite. You can make this negative, that positive. That's still going to be fine. Plug this in, and the interest rate there is going to be 5.7865%. Let's see, question 42 just asks us which has the lower rate. Well, A has the lower rate. Okay, let's get question number 43. Assume today's your 25th birthday. We're going to need a timeline for sure. So here's 25th birthday, and you make a $10,000 deposit into our retirement account. You make a deposit each birthday until you're 65, so 26, 27, all the way up to 65. So deposit, deposit, deposit. You plan to increase the amount by 3% each year. So this is a growing annuity, and your account earns 8%. How much will you have on your 65th birthday? Okay, so the value at year 65 is going to be equal to the payment. Let me make sure I got this correctly. So these are going to increase over time. So you can look back in the book and find this formula. The payment times 1 plus R to the n. Make that look better. Minus 1 plus G to the n over R minus G. Not really sure where that came from. Kind of randomly showed up. Let me just get rid of it. So the payment here is $10,000. The interest rate is 8%, 1.08, and that's 40 total years. Minus, and it's growing at 3%, 1.03 to the 40th. All this over 0.08 minus 0.03. So this is equal to $4,020,516.86. Okay, so that's a good stopping place.